What does machine learning mean? Machine learning is a part of artificial intelligence that focuses on building applications that learn from data and improve their performance over time without being programmed to do so. There are different types of machine learning, including supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the model is trained on a set of labeled input and output data so that it can learn to make predictions or classifications on new data. In unsupervised learning, the model searches for patterns or structures in the data without the help of labeled outputs. In reinforcement learning, the model learns through trial and error, receiving feedback on the quality of its actions and updating its strategies accordingly. Why Python? Python is commonly used in machine learning for various reasons. Ease of use. Python is a high-level programming language with clear and clean syntax. This makes it accessible even to those who are new to the field of machine learning. Its ease of use allows developers to focus more on specific machine learning problems rather than the complications of the language itself. Research support. Python is the language of choice among the scientific and research community, and this is particularly advantageous in the field of machine learning. As many of the new machine learning techniques and theories emerge from academic research, Python becomes the ideal tool to quickly implement these innovations and experiments. Interoperability. Python integrates easily with other languages, such as C and C++. This feature is invaluable when it comes to operating on large amounts of data or performing operations that require high performance. The ability to use external libraries written in other languages can lead to significant performance improvements in machine learning projects. Popularity and community. Python is one of the most popular programming languages in the world, with a large community of active developers. This means it's easy to find learning resources, such as tutorials, online courses, and discussion forums. The large Python community also offers valuable support when tackling problems or seeking advice on machine learning projects. Which libraries are used? Scikit-learn. This library offers a wide range of supervised and unsupervised learning algorithms, includes modules for regression, classification, clustering, dimensionality reduction, model selection, cross-validation, grid search, data preprocessing, and more. TensorFlow. TensorFlow is an open-source library developed by the Google Brain team. It is very powerful and is used to create deep learning models. TensorFlow supports a wide range of operations and methods and is highly scalable, meaning it can handle large amounts of data and complex tasks. Hard. Keras is a user-friendly interface for TensorFlow. It provides an easier and more intuitive way to build and train deep learning models. Keras supports different types of neural networks, such as convolutional neural networks, CNN, and recurrent neural networks, RNN. PyTorch. PyTorch is a deep learning library developed by Facebook's AI Research Lab. It is known for its flexibility and intuitive design. PyTorch is especially useful for research and prototype development. Pandas. Pandas provides flexible data structures, data frame and series that facilitate data manipulation and analysis. With Pandas, you can load, clean, explore, and transform data efficiently. NumPy. NumPy supports large arrays and matrices, along with a large collection of mathematical functions to perform operations on these arrays. NumPy is essential for data processing in Python. Matplotlib. Matplotlib is the main visualization library in Python. It is extremely powerful, but with a simple interface. With Matplotlib, you can create graphs, histograms, scatterplots, etc. Seaborn. Seaborn is a visualization library based on Matplotlib. It provides a high-level interface for creating beautiful and informative statistical visualizations. Seaborn is particularly useful for exploratory data analysis. How do you train a machine for machine learning? Training a machine for machine learning, or training, is a crucial process in the field of artificial intelligence. Let's see how it works. Training phase. The training set is a collection of concrete examples used to build a knowledge base or decision-making algorithm in machine learning. The machine examines this data to identify correlations between a series of input variables and a specific output variable. Learning process. In machine learning, mathematical and statistical algorithms are used which when exposed to a particular set of data during the initial training phase, autonomously derive a function. This function is capable of predicting the most probable value of y in a different data set, execution data, also providing a degree of confidence in the estimate. Parameter optimization. After the training phase, a phase of evaluation of the results and optimization of the parameters follows. This process allows the machine to improve its performance through learning, exposing the algorithm to a greater amount of varied data. Test. Finally, the effectiveness of the trained algorithm is verified using a set of tests. This set of tests verifies the effectiveness of the newly built decision tree, subjecting the machine to different situations, input vector x, to verify the correctness of its responses, decisions. Now let me show you an example of machine learning. These imports allow us to load the dataset, create the model, split the data into training and testing sets, and calculate the model's accuracy. Load iris. Loads the iris dataset. X contains the features of the flowers, and Y contains the species labels. Here, train test split divides the data so that 70% is used for training and 30% for testing. We use random state 0 to ensure the split is the same every time we run the code. Decision tree classifier creates the model, and model.fit xtrain, ytrain trains it on the training data. Model predict xtest predicts the labels for the test data, and accuracy, score, by test, predictions, calculates the model's accuracy by comparing the predicted labels with the actual ones. This line of code prints the calculated accuracy, giving us an indication of how well the model has learned from the training data and how well it performs on new data.